Today we're going to learn about the mole. Okay, so a mole is it's going to be a counting unit. Just like whenever you say that 12 eggs is the same thing as 1 dozen, right? When you say the word 1 dozen, that implies that you have 12 eggs. When you say the word 1 minute, that implies that there's 60 seconds. When you say the word 1 rem of paper, that means you have 500 sheets of paper. So just like all of these words, dozen, 1 minute, 1 rem, right? They represent one thing, but in reality, it's 500 sheets, 60 seconds, 12 eggs, right? So these are called counting units, just like the mole. We're gonna say 1 mole of something, but it really is going to imply that we have a lot more molecules. 1 mole is going to equal 6.022 times 10 to the 23 particles or molecules. Okay, so the word 1 dozen equals 12. The word 1 mole equals 6.022 times 10 to the 23 power, scientific notation, particles or molecules or atoms. Okay, so if I have 1 mole of eggs, that means that I have 6.022 times 10 to the 23 eggs. If I have 1 mole of eggs, that means that I have this many eggs. 6.022 times 10 to the 23. If I have 1 mole of pencils, that means that I have 6.022 times 10 to the 23 pencils. 1 mole of anything equals 6.022 times 10 to the 23 of that thing. The mole, or MOL for short, is a unit of measure for an amount of a chemical substance. 1 mole is also referred to as Avogadro's number, named after the scientist that came up with this number, discovered this number of particles. So 1 mole is also referred to as Avogadro's number, which is 6.02 or 22 times 10 to the 23 units. These units could either be molecules, it could be atoms, it could be particles. Remember that atom is if I have 1 element, molecules if I have a chemical compound, 2 or more elements chemically combined. So we're going to be able to use this relationship of the mole to convert between the number of particles and the mass of a substance in later sections. Where did the mole come from? This unit is called the mole, or MOL for short, right? Just like instead of writing seconds, we write S. Instead of writing meters, we write M. Instead of writing the moles after number, you could just write MOL. This number is defined as a number of atoms in exactly 12 grams of carbon-12 isotope. Remember that when you see an element written like this, okay, remember that isotopes are atoms of the same element with a different mass number. They're going to have a different number of neutrons. So carbon-12 is an atom of carbon that has a mass of 12, 6 protons and 6 neutrons. So what they did is that they got carbon-12 isotope, carbon that only weighs 12 AMU, or atomic mass unit, and they got 12 grams of the carbon, and they counted how many atoms of carbon there were, and there were 6.022 times 10 to the 23 atoms in there. So the number of particles in 1 mole again equals 6.022 times 10 to the 23. This number is also known as Avogadro's number or Avogadro's constant. Same thing. Okay, and again, it was named after Amedeo Avogadro, whose ideas were crucial in the early development in chemistry. So as you guys can tell, this number, 6.022 times 10 to the 23rd, Avogadro's number, is a very large number, right? It's to the scientific notation, and it's up to a power of positive 23. That means that there's a lot of zeros behind it, right? We would have to move the decimal to the right 23 times. It would be a number this large, right? It's a very large number, and it's hard to work with these very large number. Let's say every time we need to do a calculation, instead of using this number, we use it in scientific notation. And a mole lets us work in chemistry with very large quantities of molecules, which is actually a very small quantity of product with reasonable amount of numbers. So this right here is a mole of water. In this test tube, they are this many water molecules. So instead of having to say this many zeros, billion, trillion, we're gonna say that in this test tube, there are 6.022 times 10 to the 23 molecules of water. Okay, so moles lets us work with very large molecules. There's a lot of molecules in here of water, but instead of having to write this very large number every time, we could just say that there's this many molecules of water, or we can say that here there's 1 mole of water. If I have 1 dozen cookies, again, this word dozen means 12 cookies. If I have 1 dozen cookies, that means that I have 12 cookies. But if I have 1 mole of cookies, just like the word dozen equals 12, the word mole equals 6.02, 6.022 times 10 to the 23 cookies. If I have 1 dozen cars, that means that I have 12 cars. But if I have 1 mole of cars, that means that I'm gonna have 6.02 times 10 to the 23 cars. Okay, if I have 1 dozen aluminum atoms, that means that I have 12 aluminum atoms. But if I have 1 mole of aluminum atoms, that means that I'm gonna have 6.0 times 10 to the 23 atoms. Notice how the amount of cookies in 1 mole, the amount of cars in 1 mole, and the amount of aluminum atoms in 1 mole are the same. So we have the same amount, but the mass is not the same. Right? 12 cookies does not weigh the same as 12 cars. 12 cars does not weigh the same as 12 aluminum atoms. So just because we have the same amount doesn't mean that the mass is going to be the same. Okay, so again, just because we have the same amount, just because we have 1 mole of cookies or 1 mole of cars or 1 mole of aluminum atoms does not mean that their masses are going to be the same. This just means how many we have, not how much it weighs. 1 mole of a particle, of any particle, contains 6.02 times 10 to the 23 of that particle. So if I have 1 mole of carbon, that means that I'm going to have 6.02 times 10 to the 23 atoms of carbon, or carbon atoms. If I have 1 mole of water, again, this is about 1 mole of water. So in this little test tube, I have about 1 mole of water. And I have 6.02 times 10 to the 23 water molecules. 1 mole of sodium chloride means that I have 6.02 times 10 to the 23 molecules of sodium chloride. What is this used for? Avogadro's number is or constant can be used to convert an amount of moles into the equivalent number of atoms or grams. Today we're going to use Avogadro's number to go from the amount of moles to the amount of atoms, but by the end of this chapter we're going to be able to go from atoms to moles to grams. We're going to be able to convert from the amount of atoms to the amount of moles to the amount of grams, or vice versa. This conversion is similar to changing, for example, 8 dozen eggs into the number of individual eggs. So if I say, okay, I have 8 dozen eggs, how many actual eggs do I have? This will be the same conversion, or the same steps that you would take to figure out how many atoms I have in a specific amount of moles, or how many moles I have in a specific amount of atoms. Although this equation, from 8 dozen to the amount of eggs, is easy to calculate, and you can quickly do it in your head or in your calculator. I'm gonna teach you guys how to set it up, a strategy to set it up. We're gonna use it in this chapter, the mole, and also in the next chapter. And so first thing we need to talk about is this thing called a conversion factor. Last time we saw this was in chapter 1, I believe, when we were converting from grams to kilograms to meters, centimeters, kilometers. So a conversion factor is a fraction in which the top quantity and the bottom quantity are equal to each other. So 1 mole is the same thing as saying 6.02 times 10 to the 23 particles or atoms or molecules. We could either write it like this or like this, where 1 mole is in the bottom and Avogadro's number is in the bottom. 1 mole equals 6.02 times 10 to the 23 particles or atoms or molecules. And again, we're going to use either the top conversion factor or the bottom conversion factor, depending on the question it's giving us and when the question is asking us to find. Before we start doing some practice problems, these are some pointers that you guys have to think about. Okay, so think about what the problem before and after, and while you're doing the problem. Does the answer make sense? Don't just randomly plug in numbers into your calculator and expect to get the correct answer, right? So follow the setup. This setup is the easiest and the best way to always get the correct answer. I know it's tedious, but if you always do the steps the way I'm gonna show you, you don't have to memorize anything. It's visually, you can see what's happening, what the next step is going to be. This problem says, how many eggs are in 8 dozen eggs? Okay, so this is an easy one, and this is the one that you could actually do, probably do in your head, but I'm gonna show you how to set them up. Okay, so the first thing you're gonna do is you're gonna say, okay, what is this question giving me? The question is giving me 8 dozen. What is it asking me to find? It's asking me to find how many eggs. Okay, so the first thing you guys are gonna do is you're gonna write the number and the unit that the problem gives me. So the problem gives me 8 dozen. Okay, now I'm gonna do a line across and a vertical line. A vertical line means that we're gonna either be multiplying or dividing. Okay, next step is I'm gonna write a conversion factor. Conversion factor, and this conversion factor is going to relate the amount of eggs that are in 1 dozen. So in 1 dozen, there are 12 eggs. Okay, so I'm gonna write this as a fraction, as a conversion factor. Now, I have dozen, the word dozen up here. In order to cancel out that word dozen, I needed the word dozen down here. So I'm gonna write 1 dozen in the bottom. Oh my gosh. 1 dozen. I'm gonna write 1 dozen here in the bottom. And 12 eggs. I'm gonna write it on the top. Okay, by doing this, the unit dozen and dozen cancel each other out. The only unit that's left uncrossed is eggs. That's what the question is asking me for. So when I find the answer to this problem, it's gonna be in eggs. Okay, so now I'm gonna get my calculator and I'm gonna do 8. If the number's on top, I'm gonna multiply by that number. If the number's on the bottom, I'm gonna divide by it. So it's gonna be 8 times 12 divided by 1, which I don't really need to do this step because whenever you divide anything by 1, it's the same number. So that gives me 96 eggs. Okay, and that's my final answer. Okay, but in chemistry, we're not gonna be finding out how many eggs are in a dozen or how many dozens are in how many eggs. We're gonna be talking about molecules, atoms, moles, grams. Okay, so this question here says how many sodium atoms are there in 0.120 moles of sodium? Okay, so again, the first thing you guys need to identify is, what is this question giving me? It's giving me 0.120 moles of sodium. And what is it asking me to find? It's asking me to find how many sodium atoms. It's asking me for sodium atoms. And the first thing I'm gonna do is I'm going to start with what's given. I'm gonna write the number, 0.120. I'm gonna write the unit, MOL. And I'm also going to write the symbol or the compound or the element that this is talking about, sodium, Na. Okay, next I'm gonna set it up. I'm gonna do a horizontal line, then 1 vertical line, and my next step, I'm gonna use a conversion factor. And this conversion factor is gonna be relating moles to atoms. Use this one that has moles in the bottom, or this one that has particles in the bottom. Okay, so which one do I want to use? Notice how the question gives me the unit in MOLs, in moles. That means I have moles up here. And it's asking me for atoms. The only way for me to get rid of atoms, the only way for me to get rid of moles is to divide by moles. So if I want to cancel out this unit of moles, I need to have moles here in the bottom, meaning that I'm going to use this one that has moles in the bottom. Okay, again, a conversion factor is where the bottom and the top are equal to each other. 1 mole equals 6.02 times 10 to the 23 particles. I'm going to choose to use this one because I want moles in the bottom. So in the bottom, I'm going to write 1 mole, and in the top, I'm going to write 6.02 times 10 to the 23 atoms. Okay, by doing this, the unit of moles cancel out. Okay, the only way for me to cancel out a unit is to divide by that unit. Just like in math, just like in algebra. You get rid of a x by dividing by that x. Okay, so for me to get rid of a unit, I need to divide by that unit. They cancel each other out. The only unit that's now left uncrossed is atoms, which that's what my question is asking me for. Remember that 6.02 times 10 to the 23 could either be particles, atoms, or molecules. In this case, we're using the word atom because that's what the question is asking us to find. And if the number is on top, I multiply. If the number is on the bottom, I divide. I'm going to start by putting what the question gives me. Let's do 0.120 times Avogadro's number. 6.02 times 10 to the 23. Remember that depending on your calculator, you're going to put exponents differently. For my calculator, I'm going to use this up top hat, or this little arrow, top of the arrow, to do the exponent. 23. I'm going to press enter. And my calculator gives me my answer as scientific notation. That's what I'm going to write. 7.22 times 10 to the 23. So I have my number, I have my unit, but now I need a third thing. I need the atom that we're talking about, sodium. So that's my final answer. The answer is going to have 3 parts. It's going to have the number, it's going to have the unit, and the unit of your answer has to match the unit the question is asking you to find. And it's also going to have the element or compound. Okay, it's going to have those 3 things. And I decided to round to 3 significant figures because my question only gave me 3 significant figures. So that's why even though my calculator gave me 7.224, I rounded it to 7.22 to have 3 significant figures because that's what the question gave me. It gave me 3 significant figures. Okay, so now here we have another problem. And this question says, how many atoms are there in 3.5 moles of copper? Okay, so again, the first thing I need to do is figure out what is this question giving me. It is giving me that I have 3.5 moles of copper. That's a given. What is it asking me to find? How many atoms? Okay, so when I set up my problem, the first thing I'm going to do always is write the number, 3.5, the unit, moles or MOL, and the compound or element that the question is giving me, copper, which is Cu. Then I'm going to do this horizontal line, a vertical line, and here I'm going to write conversion factor. Okay, so here I'm going to use one of these. Either the top one where I have 1 mole in the bottom, or this one where I have 1 mole on the top. So I'm going to choose the one that I need based on what the question is giving me. Okay? So here I have 1 mole on the top. In the bottom, I want 1 mole, so I could cancel out the mole. So I'm going to use this one where the mole's in the bottom. Just like in the top. So I'm going to write 1 mole, it's the same thing as 0.6.02 times 10 to the 23 atoms. Okay, again, the reason that I do this is so that the unit moles and moles cancel each other out. The only unit that's left uncrossed is atoms, which that's what the question is asking for. Okay, so I'm gonna get my calculator again. 3.5. I'm gonna multiply times the Avogadro's number goes in the top. 6.02 times 10 to the 23. I'm gonna round to only two significant figures because my question gave me two significant figures. So it's gonna be 2.1 times 10 to the 23. Notice how my calculator gives me times 10 to the 24, sorry. Gives me scientific notation, so I need to make sure I write that. So I need to write the number, I need to write the unit, atoms, and the element that it's talking about, copper. Final answer. I decided to round the answer that the calculator gave me to two significant figures because my question gave me the number in two significant figures. So my final answer is going to have a number, a unit, and either the element or compound that the question is talking about in this case is copper. Okay, so now here we have two other problems. And this one says, how many moles are there in 3.01 times 10 to the 23 atoms of sodium? Again, the first thing I'm going to do is I'm going to circle, highlight, underline. I'm going to see what the question is giving me. It's giving me 3.01 times 10 to the 23 atoms of sodium given. Next, I'm going to figure out what is this question asking me to find. It's asking me to find how many moles. So it wants me to find how many moles are there in 3.01 times 10 to the 23 atoms. Again, the first thing I'm always going to do is I'm going to start with what's given. I'm going to write the number 3.01 times 10 to the 23, the unit, atoms, and the element that is given, sodium. Next, I'm going to write a line, horizontal line, then a vertical line. My next step is going to write a conversion fact. So am I going to write the top one or the bottom one? I need to know which unit I want in the bottom. Okay, here I have atoms in the bottom. So in the bottom of my conversion factor, I need atoms. So I want to use this one that has Avogadro's number in the bottom. Okay, so in the bottom, I'm going to write 6.02 times 10 to the 23 atoms. On the top, I'm going to write 1 mole. And again, the reason that I want this is because I want the unit atoms and atoms to cancel each other out. And the only way to cancel out a unit is to divide by that unit. I'm going to put equals because the only unit that's left uncrossed is moles, which is what the question is asking me to find. Now I need to get my calculator. Okay, so I'm going to put my scientific notation, my first number, in parentheses. So I'm going to put open parenthesis, 3.01 times 10 to the 23, close parenthesis. If the number's in the top, you multiply, so times 1, which gives you the same answer. If the number's in the bottom, you divide. So here, 6.02 times 10 to the 23, Avogadro's number is in the bottom, so I'm going to be dividing by Avogadro's number. So I'm going to put divide. Remember that when you're dividing by scientific notation, you need to put them in parentheses, okay? Because if not, that order of operation is not correct. So you need to put open parentheses, 6.02 times 10 to the 23, close parenthesis, enter. And here my question gives me 0.5. Since this one has 1, 2, 3 significant figures, I'm going to add just 2 more zeros to have 3 significant figures. I didn't change the value of the number, but I did change the amount of significant figures. So I have the number, the unit is going to be MOL, and we're talking about sodium, so Na. Answer. The next problem says, how many atoms? So it's asking me for atoms, question mark, are there in 7.5 moles of argon? I'm going to write the number, 7.5 moles of argon, which is AR. Remember that this vertical line that I do is the same thing as saying times, and then my next, my conversion factor, which if I have moles in the top, I need moles in the bottom. So in the bottom, I'm gonna write 1 mole. In the top, I'm gonna write 6.02 times 10 to the 23 atoms. Okay, so times this fraction. Instead of writing like this, I like to just draw a line all the way across. And then instead of times, I like to draw a vertical line just so I could see visually. There's one step, there's another step. Okay, now I'm gonna take the time, take the trouble, and I'm gonna go ahead and cancel out my unit. Okay, I'm doing it in a highlighter in a different color, but you could just use your pencil. But physically, go ahead and cross out these moles. Okay, so you could see that they're canceling each other out. So you can see that the only unit that's left uncrossed is atoms, which that's what the question is asking us for. So now we could go ahead and bring our calculators. We're gonna write 7.5. Since Avogadro's number is on the top, we're gonna be multiplying by Avogadro's number here. Since I'm multiplying, I don't technically have to put it in parentheses, but if I do, it's fine. It's gonna give me the right answer. But if I am dividing, I do need to put it in parentheses. If not, I'm gonna get the incorrect answer, right? For the first example, if you guys did not get the same answer I got, was because you did not use parentheses. Okay, you need to use parentheses when you're dividing by Avogadro's number. Whenever you're dividing by scientific notation, you need to use parentheses. When you're multiplying, not necessary. So equals, and it gives me 4.515 times 10 to the 24 power. Okay, I'm gonna look at my question. It gives me the number in 2 significant figures. So I'm gonna round the answer the calculator gave me to only having 2 significant figures. So 4.5 times 10 to the 24. I have my number. Remember, my answer is in 3 parts. It needs a number, it needs a unit. What unit is it gonna be? The unit that was left uncrossed, which should be the same that the question is asking you for. And the element that the question is talking about, which is argon, AR. Okay, and that's my final answer. Okay, so number 1 says, how many atoms are present in 3.5 moles? So again, find out what's given. 3.7 moles of sodium. It's asking me to find how many atoms of sodium are present. So for number 1, the first thing I'm gonna do is I'm gonna start with the number that's given me. 3.7 moles of sodium, which is Na. I'm gonna do my vertical line, my horizontal line. My next step is gonna be a conversion factor. Use the one with the moles on the bottom or the atoms are in the bottom. In this case, since I was given the moles, I want moles in the bottom so I could cross out the moles. So in the bottom, I'm gonna write 1 mole. On the top, I'm gonna write 6.02 times 10 to the 23 atoms. Okay, remember that a conversion factor, the top quantity and the bottom quantities are equal to each other. In 1 mole, there's 6.02 times 10 to the 23 atoms of anything. But I wrote it this way with moles on the bottom so that moles and moles cancel each other out. Again, take the time, take the trouble, and actually cancel out the units. So you can see that atoms is the only unit that's left uncrossed. And that's what the question is asking you for. If the number's on top, you multiply by it. If the number's on the bottom, you divide by it. Always start from left to right with the number that's given to you. 3.7 times 6.02 times 10 to the 23 equals. My calculator gave me 2.2274 times 10 to the 24. My question gave me the number with 2 significant figures, so I'm gonna round my answer to 2.2 times 10 to the 24. I'm gonna round my answer to 2 significant figures. Atoms of sodium. I run out of space. Okay, and that is my final answer for number 1. Okay, now number 2 says, how many atoms so it's asking me for atoms, are present in 155 moles of arsenic. That's a lot of moles of arsenic. So that means that I expect to have a lot of atoms of arsenic. Okay, so when I set up the problem for number 2, I'm gonna again start with what's given. 155 moles of arsenic, which is AS. Then I'm gonna do my vertical line, my horizontal line. Again, remember that every time I do a horizontal line, as I say, in times and then a fraction. So in this fraction, this conversion factor, remember that since I have moles up here, I'm gonna use this one moles on the bottom so that the units cancel each other out. A conversion factor is a fraction in which the bottom and the top are equal to each other. So in 1 mole, there are 6.02 times 10 to the 23 atoms. Again, guys, take the time, take the trouble, and physically, with a highlighter, with a pen, with your pencil, it doesn't matter, cross out the units so you could see that the only unit that's left uncrossed is atoms. That's what the question is asking us to find. Okay, so now I'm gonna get my calculator. Since Avogadro's number is at the top, I'm gonna be multiplying by Avogadro's number. So I'm gonna start with, from left to right, with what was given first, 155, times 6.02, times 10 to the 23. Enter. My calculator gives me 9.332 times 10 to the 25th. Again, my question gave me the number in 3 significant figures, so my answer, I'm gonna round it to have 3 significant figures. So 1 significant, 2 significant, 3 significant. I'm gonna round it to 9.33 times 10 to the 25 atoms of arsenic, which is AS. Final answer. Again, my answers should have 3 parts: a number, a unit, and the element. Okay, and the last question says, how many moles of xenon are there in 5.66 times 10 to the 26 atoms of xenon? So it's given 5.66 atoms of xenon, and it's asking for moles. So the first thing I'm gonna do again is write what was given to me. 5.66 times 10 to the 23 atoms of xenon, which is E. My horizontal line, my vertical line. Next step is I'm gonna write a conversion factor. Whatever unit I have here, whatever unit is given to me, atoms, I want it at the bottom of my conversion factor. So in the bottom, I want here atoms. So that means that I need to write Avogadro's number in the bottom. Atom, and on the top I'm gonna write 1 mole. Again, the reason that I want atoms at the bottom is because I want atoms and atoms to cancel each other out. Again, take the time, take the trouble, cancel out the unit, either with a highlighter, a pen, or your own pencil. Cancel out the unit. Notice that the only unit that's left uncrossed, moles, is the unit that the question is asking us for. Now I'm gonna get my calculator. Okay, I'm gonna do 5.66 times 10 to the 23. Start with the number that's given first, then go to the right. If the number's on top, I multiply by the number. If the number's on the bottom, I divide by the number. So here I'm gonna be dividing by Avogadro's number by scientific notation, so I need to use parentheses. 6.02 times 10 to the 23, close parenthesis. My number was given with 3 significant figures, so I'm gonna round my answer to 3 significant figures. It gives me 0.940199339, so I'm gonna round it to 3 significant figures. 940 moles of xenon. That's my final answer. I do not need to write it in scientific notation. It's a small number, but if I were to write in scientific notation, it would be 9.40 times 10 to the -1 moles of xenon. Okay, so just a little recap. Remember that the mole is a unit measure of an amount of substance. A mole is also referred to Avogadro's number, and that is 6.02 times 10 to the 23 particles. So if you see the word 1 mole, or the word Avogadro's number that is implying to this number 6.02 times 10 to the 23 units, either atoms, molecules, or particles. We can use moles relationship to convert between the number of particles, which we just did, and the mass, which we're going to do next lesson, of a substance. I hope this helped.